So word problems. The thing about word problems is we like to think of them as the harder ones, and they are in some ways. But then, one of the things that gets people about math is, oh my God, there's all these X's and Y's and Z's and variables, and that's what makes things hard. And what it turns out is that all this stuff about setting up variables and remembering properties and solving equations is what takes these problems and makes them easier. And it turns out then that the hardest step, or the step people struggle the most with, is that step of figuring out, okay, what's the equation here? Because once I get an equation, I can solve it pretty well, as is evidenced by this test. People did pretty well on this test. And the key to doing these right, there's a couple keys. One is a mental key. I really need you to let go of the idea that you know the answer right off the bat. That's usually what we think of when we think of questions, is we think we only want an answer. And you should be able to look at the question and get the answer right away. Or look at the question, maybe think about it for a second and get the answer. And word problems are the first case you'll see that are really not like that. Word problems are going to require you to make progress, to get insights, not necessarily to get the right answer right away. And so I encourage you to use a set of steps, more than encourage. It's strongly encouraged, pretty much required. And it's these steps that the book gives, it's somewhere in section 2.4, and I've added one that I think is just really critically important. That's that one called 1A that's in bold. That's one that, I cut and paste this thing out of the book and then I wrote 1A in. So let's look at these steps. So first of all, you analyze the problem. You basically read the problem. That's the key thing. You read the problem. You may have to read it more than once. You may have to read it once casually and then a couple times a little more seriously. If there's a picture that would help, this book you'll see draws sometimes the pictures, but sometimes having a picture is going to help you, and so you're going to want to draw the picture yourself. 1A tends to be the first thing I ask you to write. Actually, step back. There's something. The first thing I tend to write is, let's look at this first step. It says, analyze the problem by reading it several times, what information is given, and then there's this question, what are you asked to find? And I will actually get to where I make you write that down. What exactly is it you're being asked to find by the problem? The second step then is that step I call 1A, is also pretty critical. It's what's called a let statement. Now a let statement is going to be key in helping you translate the problem from being a verbal problem to being an appropriate model, an equation that you can solve and actually get the problem right based on it. A model, an equation that makes sense. Okay, I use that word model. Mathematicians use that word model sometimes to describe an equation in this context, because what it is it simplifies the problem. It boils it down into one line, what's going on. We want to find the x that makes this statement true. It cuts away all the other layers of confusion and says this. But part of cutting those layers away is knowing what you're going to let x stand for. Finally, once you let x stand for, then you form the equation based on the statement of the problem. And once you've done that, it's fairly straightforward to solve the equation. state the conclusion, check the result. All that's straightforward once you've done that. But the key things people want to skip, and the things I'm going to kind of beat on you not to skip are those first two steps. Find what is it you're being asked to find, and what are you going to let the variable x be.